Hello everyone, welcome to the video lecture series on Mechanics of Solid subject. So myself Dr. Renangi Sandeep. Today I am going to discuss about stress strain curve for both ductile as well as brittle materials. So first, what is the need of stress strain curve? Why we need to study that one? So let us suppose we developed one new material for the particular application. But that material we don't know whether it is brittle in nature or ductile in nature. So that one we came to know by conducting the tensile test on the particular newly developed material. So from the test results we will get some graph. So that graph is nothing but stress strain curve. So from that graph we came to know the newly developed material is brittle or ductile. If it is brittle, what is the maximum breaking load? And then if it is ductile, what is the maximum deformation taking place before the failure of the product? So these kind of material properties we came to know by using of stress strain curve. And then coming to the stress strain curve for the ductile material like mild steel. So if the ductile material like mild steel is subjected to tensile load, it will undergo different stages. So those are proportional limit, elastic limit, yield point, ultimate tensile strength, and then breaking stress. So what is proportional limit means? So this is the point up to which stress is directly proportional to strain. So which means that up to this point if we apply the some load, so the same amount of deformation will going to take place linearly up to this point. So this is called as proportional limit. So this one we will also call it as Hooke's law. So the proportional limit is stress is directly proportional to strain, which is also called as Hooke's law. And then the next point is elastic point. So elastic point means the point at which the material will regain its original shape and then size of the product after removing the external load. So let us suppose see this one. So this is our original material, and then if we apply the load, it will deform something, some length. So once after removing the external up to the elastic limit, the material will able to regain its original shape and size. So this one will happen up to the elastic limit. So and then next thing is yield point. So yield point means the point at which the material deforms plastically. So which means that, so if you this is our material, and then if you apply the load, it will deform some distance, and then once the material reaches the yield point, the material cannot able to regain its original shape and then size of the product. So if you observe this diagram, it is having some small length. So once it was applied the load, it will deform, means it is increasing the length. And then if it went to yield point stage, so the material won't regain. See the length difference of base material after the yield point, what is the length? So that one we'll call it as yield point. And then the next one is ultimate tensile strength. So the ultimate tensile strength means this is the maximum stress the material can withstand before rupture. So at this point we will get the complete necking during the tensile test. And then the next point is breaking stress. So breaking stress means this is the load up to which the material will fail, completely failure will occur. So see this diagram. So up at this particular point, the material will come into two parts after the necking process. So this is the load of the material which failure taking place. So this is the stress strain diagram curve for typical ductile materials. And coming to the next one, that is stress strain curve for the brittle materials like cast iron. So when the brittle material like cast iron is subjected to tensile force, it will undergo different stages before the failure. So those are proportional limit and then breaking stress. So here the proportional limit is nothing but the point up to which stress is directly proportional to strain. And then breaking stress, here we won't get any ultimate tensile stress and then elastic limit, since for the brittle material there is no deformation or very small amount of deformation, so that we will get directly breaking stress. So here the breaking stress means the load at which complete failure of the material will occur. So that is about stress strain curve for the brittle materials. And then now see how we can identify the material property like ductile or brittle materials by using of stress strain curve in the real time example. Now let us suppose I develop two new materials, that is material A and then material B. So I want to know whether the materials are ductile or brittle in nature. So that I was conducted a tensile test on both the materials as per the ASTM E8M standard. So from the test results I got two graphs. This is first graph and then this is second graph. So from the first graph it was identified that the graph which was obtained for the material A is just look like the stress strain curve for the ductile material, and then the graph which was obtained for the material B is look like the typical stress strain curve for the brittle materials. So which indicates that the material A will behave like as a ductile in nature, and then the material B will behave like as a brittle in nature. Now I want to identify the ultimate tensile strength and then elastic point for the material A. So how we can obtain means, so we need to draw a line for the top of the graph like this towards the load. So from this graph it was identified that the maximum ultimate tensile strength which was obtained around 19,000 newtons. So after this point the material may fail. So here only the necking will form, and then I want to identify the up to what load the material will behave like elastic in nature. So see this point, so we need to draw horizontal line like this. So from this graph it was identified that the material will behave like elastic up to the nearly 11,000 newtons. So after 11,000 newtons the material will undergoes to yielding, which means that the material will undergoes permanent plastic deformation. So like a way we need to identify ultimate tensile strength, elastic limit, and then yield point for the ductile materials from the stress strain curve. And now see how we can identify the breaking stress for the brittle material. So if you observe the diagram, so from this graph we need to draw the horizontal line towards the load from the maximum point of the curve. So from this graph it was identified that the breaking stress is around 9,000 megapascal in terms of stress. So like a way we need to identify material properties like brittle or ductile, and then if it is a brittle, so what is the maximum breaking stress, what is the proportional limit value, and then if it is a ductile in nature, what is the ultimate tensile strength, and then up to what load the material will act as elastic, and then from what point the material plastic deformation will occur, and then we will get the failure point also for the ductile materials. So like a way we need to identify the unknown material properties by using a stress strain curve. Thank you.